a resource specialist with Portage County. I'm one of the two principal investigators on this project. With us tonight, which will be presenting, our Dr. Carla Romano, who is our postdoctorate researcher, who did the bulk of the work on this project and who will be sharing the results with us this evening. And then Mike Parsen from the Wisconsin Geologic and Natural History Survey as well, who will be talking this evening. So I want to welcome you all to this public presentation and rollout event for what we're affectionately calling the short name, the Central Sands Nitrate Neonicotinoid Study. It has a much longer title, which you'll see a little bit later in this presentation. There are a number of people who have worked on this project throughout the last year and a half, and so we'll give kudos to them throughout the presentation and stuff. But this is a little bit of an outline for this evening's agenda and what we'll be talking about. I'll be giving kind of a short background on how this project came to be and how it kind of, came into coming. Dr. Romano will be sharing the study findings. Mike will be sharing the final deliverables, and we'll be talking about what's next. And then we've saved a good chunk of time at the end for any questions. We are going to ask, kind of as a housekeeping thing this evening, if you could save your questions until the end. We are video recording this presentation with closed captioning to be posted on a website following this presentation. And so just for video editing purposes, it'll be easier if we can save those questions till the end of the evening. So we'll get things started. This project really kind of came about in a very unique way. So I don't know if any of you are familiar with this group, the Central Sands Groundwater County Collaborative. This group started meeting about 5 years ago, and it really came from a group of county board supervisors that got together and really started to recognize, look, we're all dealing with very similar issues when it comes to groundwater. And while we have, geopolitical boundaries that we stay within when we kind of regulate and talk about policy, groundwater really doesn't. And it really doesn't make sense for us to try and address these issues, each within our own little space. What if we started working collaboratively together on this? And that's really where this group of counties came about. So it's 6 counties in the Central Sands area that got together and started talking about, okay, what are our issues? What do we know about these issues? How do we want to try and tackle these things as we move forward? The collaborative is made up of representatives from multiple different county departments. Each county has a county health department representative that serves on the collaborative. A land and water conservation member sits on there. Occasionally we have planning and zoning that also serves, and then extension individuals are also within that meeting. And then the county board supervisor also serves on that county collaborative. So it's all levels of government that are trying to work together collaboratively in the name to address these issues. When this collaborative started to work together and talk about these issues, one of the things was, okay, what do we want to do? What do we want to tackle? And so the first thing that came up was, well, testing. Some of the counties were testing, some counties weren't, some had done periodic testing. We're like, we should really do more testing. And so we reached out to people at the Geologic Natural History Survey, the University of Wisconsin Stevens Point, and DATCAP to kind of get their opinions on, okay, if we do testing, what kind of testing should we do? And they said, whoa, time out. We have a lot of information in this area of Wisconsin. There's been a lot of data collected over the years, a lot of studies. I think maybe we should start there. And that's really where this project was born out of. It was to kind of answer and evaluate these 3 questions, because these questions are what the counties felt was important. What data and tools on nitrate and neonicotinoids are available in the Central Sands region already? What do these tools and data tell us about the groundwater quality? So what do we have? What are they telling us? And are the data and tools that we have adequate to identify the most effective and strategic management options? Or do we actually need more? And it was with those 3 questions in mind that we put together a grant proposal for the Wisconsin Joint Solicitation for Groundwater. And that's where this project was actually funded through and came about. So with that, I will turn it over to Dr. Romano for to talk about the actual study and findings.
So thank you so much, first of all, for being here. As Jen said, my name is Carla Romano. I'm currently a hydrogeologist at the Wisconsin Department of Agriculture, Trade and Consumer Protection. But while I was conducting the study, I was at the Geological and Natural History Survey. So today I'm gonna walk you through, of course, a little bit about the goals of the project, but mostly we're gonna focus on the findings related to the data compilation, to the nitrate and the neonicotinoids. So I guess it's pretty much common knowledge that we do have a problem related to nitrate in groundwater in Wisconsin. And there are certain areas of the state that are definitely more vulnerable to this issue. And one of these areas is actually the Central Sands. This has been an issue for decades. There's still quite a lot of wells that get tested and nitrate concentration are found above the drinking water standard of 10 milligrams per liter. And while we're still trying to solve this issue, there are new contaminants that are kind of emerging in our waters. And I'm talking about specifically neonicotinoids. I don't know if you ever heard about this word, but these are kind of a group of insecticides, and there are 6 types of neonicotinoids, but primarily there are 3 types of compounds that we find in Wisconsin, and these are chlorothianidin, imidacloprid, and thiamethoxam, as we're going to see later. Why do we care about these compounds? Is that there have been some research finding that these compounds are actually particularly harmful for pollinators, but also to fish, mammals, and potentially also some of them to a certain level for human health. So as Jen anticipated before, there were several questions that we wanted to answer with this project. What data is out there? Is the data enough? So first of all, we decided to compile the available data on the nitrate and neonicotinoids in the central sand region of Wisconsin, and particularly behind this little window that shows me that map has the 6 counties that are involved in the area. We wanted at first evaluate also the extent of the contamination, identify gaps in the data in both space and time, and also evaluate which factors and at what extent these factors affect the contamination for nitrate and neonicotinoids. First step is groundwater quality data gathering. So the first step for us was to kind of understand, okay, what is out there and how can we get this data? So we kind of reached out to individual institution, or we downloaded data that was out there publicly available, and we come up with a list, that pretty extensive list for nitrate data that start with DACAP or the Environmental Protection Agency, particularly the Juneau County study. We included the Wisconsin Department of Natural Resources data, as well the U.S. Geological Survey data, the UW Stevens Point data, and some individual study done by the Department of Geoscience at UW-Madison, and as well all the data that, as again Jen said, was sporadically collected by the counties, such as from Juneau, Adams, Portage, and Wood County. When it comes down to neonics, which is the short name for neonicotinoids, so if you want to get a little bit, an easy route for talking about, so the neonics data have only 2 main sources. So we're mostly gather data from the Department of Agriculture of the state of Wisconsin and the U.S. Geological Survey. Why do we have less amount of data? It's purely because neonics were first registered in Wisconsin at the end of the 90s, early 2000s. So there's definitely a shorter amount of time that we use these products. So as we're going to see, the sampling is definitely increasing over time, but we're definitely in a different kind of, contaminants and use of this product compared to nitrate. So for answer the questions and to kind of perform data gap analysis or to understand what factors control the contamination, we couldn't just gather basically data related to nitrate concentration and neonics. We had to take a little bit of a step forward and at the minimum get data on the well location, on the sampling data and the concentration to perform the data gap analysis in both space and time. But we also decided to include data related to well characteristics such as well depth, casing bottom depth, well construction type, well construction date, and as well also consider numbers of septics or land use, particularly agricultural land use and soil properties as potential factor that might influence the contamination. So when I combined the data, I had all these sources and I thought, okay, this is going to be easy. You know, I have several data sets that have some information in common. I'm just going to merge the two data sets and call it a day. The reality was actually completely different. We had a lot of mistakes in the data. We had a lot of bumps along the road, and I don't want to, spend the entire night talking about it, but just to give you a couple of examples, we had, for example, well, let's say XYZ123 that was located in different sections depending on what data sets we were querying. Or we had some wells that had surprisingly a depth that was shallower than the water table or the casing bottom depth, which is, not possible. Or, for example, we had some data saying that the well was sampled after it was constructed. So there is definitely a little bit of an issue related to the data per se. So our strategy was to kind of start and compare the different data sets. We were trying to understand how much good data we had and how we could basically classify the data as good or not that good. So we decided to assign an accuracy level to the well characteristics and the well location. So if you're going to dive into the database, you're going to see that every time you have like a well depth, you're going to also have, is this measurement accurate, yes or no, and where the source of that information is coming from. How did we decide if a well depth perhaps was, accurate or not? We kind of compared different data. So let's say we have 4 data sets, 3 of them say that the well has 100 feet, deep. And then we say, okay, if 3 data sets say that that's 100 feet, then we're going to take that as a good information. But just to give you kind of an idea of the about 74,000 data points that we collected for nitrate collected in non-public water system, about only 45% of the data has a good, accurate well depth, for example. So lesson number 1, there is definitely a little bit of improvement that we need to do in the data storing, the data sharing processes. And this is kind of like, everybody that is involved, any stakeholder is involved in data collection and data sharing should kind of like probably hear this message, and we should all perform data quality check before sharing and include in the data set as many information as possible, because that's going to facilitate and help a lot with the data merging and, the data compilation and processes such as duplicate checks. So we learned something about the data compilation, the struggle, the challenges, but also how we overcame that. So now we're going to dive into a little bit into the nitrate part, which is the majority, honestly, of the data that we collected and also of the study that we at the time that we spent for the study. So what you see here is the nitrate average concentration per section for the CSGCC area, and that includes all the data collected from 1953 to early 2022, and particularly it was like the end of February, the last measurement that we included in the data in the database. First measurement is 1953. That doesn't mean that nothing was sampled before. Maybe was, but it was purely just not stored and we couldn't find it. We gather a total of 74,000 data points. What you see in white is, our sections that have an average nitrate concentration per section between 0 and 5 milligrams per liter. What you see in orange is between 5 and 10 milligrams per liter. And And what you see in red is instead above 10 milligrams per liter as an average concentration per section. And we are considering here non-public water systems, which primarily include private, potable and non-potable, and monitoring wells. So they're kind of like all gathered all together. So what it's showing up from this map is that we have like a major kind of area here that goes across Adams, Waushara, and Portage County that has an average nitrate concentration that it's above the drinking water standard of 10 milligrams per liter. It's been identified by several other data sets as well, and it's along pretty much the groundwater divide of the central sand region of Wisconsin. We also have this other area here northeast of Juneau County that also seems to show a high concentration of average nitrate per section. So the beauty of this database and in general this nitrate data set is that actually we can sample kind of through time and see things how it changed over time. So what you see here is pretty much the same concept. We have the same map showing the nitrate average concentration per section. But this time we're only taking into account data between 9053 and 9067. And as you can see, there's not a lot of data. So that means A, that we were not sampling back then, or B, again, that data was not basically stored, even though it was collected. So, and again, we can just like do this for every 10 to 5 years. You see here the data between 1967 to 77. There's definitely Portage that starts, like Portage County starts sampling for nitrate, followed by Wood and then Juneau and a little bit of Waushara in the next decade between 1977 and 1987. And then we can just keep going, 1987, 1992, 1992, 1997, all the counties are studying like ramping up with the sampling, 1997, 2002, 2002, 2007, 2007, 2012, 2012, 2017, until we arrive now at what it's happening the last pretty much 5 years. So how are we doing in terms of sampling? As you know, it was probably clear just qualitatively looking at the maps. We definitely have increased the sampling around this time here between the 80s and the 90s. What this graph shows are the year intervals every 5 years versus the total amount of either measurements in orange or wells in green or sections in blue. And in general, it looks like we did sample more and more over time. There is a little bit of a plateau here, kind of like we reach, kind of a stable amount of measurements collected throughout the time since the early 2000s. And whenever you see, for example, in this part here where the measurements is stable, but the wells are ramping up, it means that we were collecting more and more data from like different wells. So we were collecting the same amount of data, but from more wells. So one of the main kind of deliverable that we handed to the county, and hopefully this is like a great tool for them, was actually to develop a map that would show what sections were never sampled and what sections were not sampled in the last 10 years. However, we do know that in the central sands region of Wisconsin, there's some areas that do not have any well or septic. So what we did to kind of give a more insight, on and more usable information, we kind of used the nitrate data, we used the well location, and we used the septic system location to identify what section had at least a well and a septic, and then understand what section then was never sampled, or what section was not sampled in the last 10 years. So, if I'm a person from the county perhaps, and I just want to start filling the gap, and I have some funds and I want to do some sampling and I just want to sample somewhere, then perhaps I might want to use, this as a first start of where to go for, again, filling the gaps. So one of the most kind of like recurring question that I had during this project was like, okay, so is the nitrate getting better? Is it getting worse? Is it stable? What are we doing? One of the question was, are we getting better compared to the 60s? And I cannot answer that question because as I shown before, we didn't have really a lot of data from the 60s, and I can really not say anything about it. We can kind of say something about before the 90s and the last 5 years, but again, there are individual sections that kind of like change things. There's something improving, something getting worse, something stabilizing, or like that it's pretty much stable. And that also depends on the fact that we are here assembling all the data that is collected to wells regardless of their depth. So there might be some variation and might be more trend when you kind of look at different kind of well groups based on like well depth perhaps, or well characteristics and so on. And so this is kind of like one of, we compile all this data. We had 11 months to do this project, but there's so much more that can be done with this database. And I hope that, everybody out there can have a look at it and use the data for more and more and more research. So what we just kind of like give you a quick answer, or to give a basic answer of what is going on in terms of trends. What we decided to do is to take into account townships. So we're kind of like at a larger scale than a section. And we decided to plot just, for each township, the average nitrate concentration per year versus the year. And what you can see here, there isn't really like, for example, a trend for this township here, or West Washera. The nitrate goes up and down. It's definitely a lot scattered before the early 2000s. There's a little bit of more consistent sampling done afterwards. But what we can say about it is that I don't really see a trend. There is no statistically significant trend. But what I can say is that the majority of the measurements are actually above the threshold of the 10 milligrams per liter. And we did this kind of exercise for all the townships. So if you look at the report in the appendix, you can find basically every township has one of this graph, as long as there was at least like a sample, 2 samples collected for that township. So, what can we say about what we just saw? So to see trends over time, I mean, that the findings of this study, and probably people knew this already, is that the sampling strategy cannot just be focused on filling the gaps. I've seen a lot of like effort of doing, okay, let's just sample a township that we never sample, or a section that we never sample. But if you do want to understand what are trends over time, then perhaps you want to think a more strategic way to actually collect samples. Go back to wells that you didn't sample in the last, 5 to 10 years, or wells that had a high level of nitrogen and you don't know what happened to that afterwards. So it has to be a little bit of more like thoughts in the sampling process that is beyond just like, let's fill the gaps. When we talk about understanding the extent of contamination, we didn't want to just like look at things, on a 2D, so in X and Y, lat and long, but we also wanted to start looking at things a little bit also in depth. Because we did have the information about the well characteristics, right? We collected data on the well depth, the well casing bottom, and the static water level. So what we did for each township, and again, you can find this in the appendix C of the report, and this was actually an idea of Matt Silver from the Department of Natural Resources. We created these plots that I'm going to explain, and they're highly informative. What you see here for each of these data points is not an average, the actual nitrate data that was collected in this township here. So you have the nitrate concentration. Each data point is one sample. You have this red line that it identified the drinking water standard of 10 milligrams per liter. And on the y-axis, you have the difference between the water table minus the casing bottom depth, which is another word is kind of like a depth below the water table. So the graph kind of like identifies the nitrate versus the depth below the water table. So how deep below the water table we need to go, or we do find basically nitrate concentration that exceeds the 10 milligrams per liter. The color also gives information about the timing of the sample. So whatever you see in red is basically old data. Whatever you see in blue, it's most recent data. So when you see this graph, you can tell, okay, I'm in this township. I have quite a lot of data, and it's a mix between old and new data. And, you know, if I want to understand what is the maximum depth below the water table I've ever found nitrate above 10 milligrams per liter, I can just quickly see, okay, it's over 80 feet below the water table, right? But if I want to just look at more recent data, so I just look at the blue points, then I can say, okay, concentration above 10 milligrams per liter were found at about 70 feet below the water table. And we did, again, this exercise for all the township. And I hope that this, you know, will be really useful for future. So let's jump into like, okay, so now what factors control the contamination? We utilize a similar strategy that was used for this week's study in Southwest Wisconsin. We use something called logistic regression models, which are basically a statistical way to identify the probability of that an event occurs due to a certain variable. So our event is the probability of having a nitrate concentration exceeding the 10 milligrams per liter. And our variables are well age, well depth, septic system, ag land use, and soil properties. And we took into account one variable at a time, so it's not a multivariate approach. So let's start with the well age. So this graph here shows the well age that expressed in years. And so we had wells that were very recent up to like wells that were 100 years old. And here is expressed the probability of the nitrate of being above the 10 milligrams per liter threshold. This 0.0 to 0.5 can be just multiplied by 100 and be expressed as a percentage. So as you can see here, we have that the probability of having nitrate concentration above 10 milligrams per liter increases as the well age increases. So just for example, if I have a well that has, you know, was constructed yesterday, I have about a 9% probability that the nitrate is going to exceed the 10 milligrams per liter. While if I have a well that is pretty much 100 years old, then I'm going to have a 22% probability to have a nitrate concentration above 10 milligrams per liter. So this is how to interpret this kind of graphs. We did the same exercise with the well depth, and we found that the probability of having nitrate above the drinking water standards decreases as the well depth increases. And that means that basically if you have a well that it's shallower, you have a higher chance to have a high concentration of nitrate. And the probability goes between like 12% to about 0% when your well is around like 400, 500 feet deep. We look at also soil properties, and that took a little bit of a while because, as you know, there are different types of soil for different sections, and soil changes with depth. So what we came out and what we decided to do is to calculate the weighted average hydraulic conductivity of the most predominant soil unit within a section. So what we did is then calculated the weighted average based on the thickness of the horizon. So basically the importance of the hydraulic conductivity that was given to a certain soil horizon was dictated by the thickness of that horizon. And what we found is that the, here we go. Is that the probability of having nitrate concentration above the 10 milligrams per liter increases as the soil hydraulic conductivity increases. Not a surprise if you have a more permeable soil, you know, there's going to be more probably chances to infiltration, and so the nitrate concentration is likely going to go higher, going to be higher than if you have a low hydraulic conductivity. We did the same exercise for clay content. And we found that the probability of having nitrate concentration above the 10 milligrams per liter decreases as the clay content increases. So the more clay content you have, the less chances of nitrate above the 10 milligrams per liter you're going to have. And the probability goes between 50% to 10%. There's not a lot of change. That means that like between all the variables, probably this is not the most effective one. We did again the same exercise for the organic matter, and we took into consideration the clay and organic matter because a lot of, compounds in general might stick to the organic matter and to clay, and so there might be some sort of adsorption and perhaps some degradation process that might prevent the leaching of the nitrogen into the groundwater. What we found here is that similarly to clay, that the probability of having nitrate concentration above the 10 milligrams per liter decreases as the organic matter content increases. We also look at septic systems. So the county kind of gave us information about the numbers of septic, and we kind of calculated the numbers of septics per section. And what we found that actually that the probability of having nitrate concentration above the drinking water standard decreases as the number of septic system increases. And that was kind of switch to what we were thinking. And that could be related to the fact that septic system is a concept that is still very much connected to a land use. So there might be related to the land use different variables that are interconnected to each other that might play a role. And because we are now here just taking one variable at a time, we're not able to capture that behavior. So what we did for taking into account the agricultural land use, we did something that was kind of similar to what was done for the Central Sense Lake study. But what we thought is that, okay, I have the Wiscland agricultural land use, which is a very recent 2019, 2020 layer of land use that was developed by the Wisconsin Department of Natural Resources. But we do have data from the 1950s. So we cannot just use the most recent land use data and just assume that land use never changed in 70 years. So what we did, we kind of compare and we kind of calculate the percentage of land use in the 30s and what it is right now. And we decided to only take into account the data and the sections that had a similar percentage of agricultural land use, plus or minus 10%, just because things might change, and so on. So we kind of only took into account basically the land use that pretty much did not change since the 30s, just to be kind of more faithful to the data statistical analysis and to the data that we were considering. So what we found here is that the probability of having nitrate concentration above 10 milligrams per liter increases as the percentage of agricultural land use per section increases. So just to give you an example, if you are in a section where the percentage of agricultural land use is 20%, you're going to have a probability of about 10% to have an exceedance of nitrogen for the drinking water standard. And if you are in in a section where the agricultural land use about 80%, then you're gonna have about a 50% chance to have a concentration of nitrate above 10 milligrams per liter. So here are some takeaways about nitrate. We compiled over 70,000 data points just for nitrate collected in non-public water systems, so private and monitoring wells, for the Central Sense Groundwater County Collaborative area in the last 70 years. The amount of sample collected, wells sampled, and sections sampled did increase over time. And we couldn't find any increasing or decreasing or trend that by just looking basically at the average nitrate concentration per year per township. Increasing well age, hydraulic conductivity, or percentage of agricultural land use per section increases the probability of having nitrate concentration exceeding the 10 milligrams per liter. And increasing well depth, soil clay content, or organic matter content in the soil decreases the probability of having nitrate concentration exceeding the drinking water standard. So let's jump in now and switch gear and go into neonicotinoids. The story is going to be a little bit shorter just because purely we couldn't do all the things that we've done with the nitrate, and I'm just going to show you why. Primarily, we couldn't do any gap analysis because there's not enough data to basically identify gaps because there are more gaps than actually data. And so it's kind of it's normal. Again, we've been only sampling for these compounds in the last 10 to 15 years compared to nitrate, where we have data for the last 70 years. And just to look a little bit more in depth, this is a map that shows the average chlorothianidin, so one of the 3 neonics compound, concentration in groundwater. We are again considering just private and monitoring wells, so non-public water systems. And everything that is in yellow and orange and red is above certain standards and threshold. So currently there are no enforcement standard or drinking water standard or preventive action limit established for these compounds. We do have standards that were established by the Environmental Protection Agency for invertebrates, so they're mostly related to surface water, but you know, the central sense that there is a lot of surface water and groundwater interconnected, so we kind of decided to make that comparison. But there are currently health advisory level that were issued for these compounds by the Wisconsin Department of Health Services. So again, there are no groundwater drinking water standards for these compounds established. They're just advisory level for human health. But there are standards established by the Environmental Protection Agency instead for invertebrates. So what you see in the yellow here is everything that is pretty much above either a chronic aquatic life benchmark for invertebrates or an acute or advisory level. Although, as you can see, the maximum amount of concentration that we found as an average was 1.27 as an, again, average concentration of chlorothianidin per section, that it's well below the 1,000 micrograms per liter that is the threshold at advisory health advisory level issued by the DHS. And regardless of the average, we did not find in the data anything that was above this threshold for human health. We did the same for imidacloprid. You can see here that the sampling was pretty much focused in the same area where the nitrate was found at high concentration. It was done probably from a strategic standpoint because sometimes whenever you have a leaching of nitrate, there's potential of leaching of other compounds as well. But it's not a one-to-one relationship. You know, you've seen that in this area we had a high nitrate concentration and we do not really detect imidacloprid. So there's definitely a difference in the transport behavior of neonicotinoids and nitrate. You see again here the standards and the aquatic life benchmarks established by the Environmental Protection Agency, and again the health advisory level issued by the Wisconsin Department of Health Services for imidacloprid. And everything that is in yellow, orange, and red defines basically an exceedance of one of the 3. We do have exceedances, as we're going to see in the next slide, of the health advisory level for imidacloprid. And, you know, if we jump into thiamethoxam instead, we can see that this is probably the less kind of like detected compound of the 3. Again, you have here the aquatic life benchmark and the health advisory level for thiamethoxam. We really have never seen like this high of a concentration for health advisory level. Pretty much, you know, whenever you have seen a high level of concentration of chlorothianidin, and for example, here or here or here of chlorothianidin, there is also a high concentration, even the imidacloprid, and also a little bit of thiamethoxam. So these might highlight areas that are particularly vulnerable to the contamination for these compounds. So just to kind of summarize, these are plots that show the year of sampling versus the count of measurements that were either, you know, collected, so in white, detected in blue, and in yellow were the measurements that were above the chronic aquatic life benchmark for invertebrates. In orange was the samples and the count of measurements that were found above the, oh, this might be switched. Actually, above it's actually switched. So the orange should be, I'm sorry about that. So the orange is the above the aquatic life benchmark for invertebrates, and in red we have the above the Wisconsin Department of Health Services health advisory level. So You see in red, this is basically everything that is above the health advisory level. Again, in orange here, everything that was above the acute aquatic life benchmark for invertebrates. As you can see here, there's definitely an increase of sampling over time for all the three compounds. We have been sampling for thiamethoxam for prior the other two compounds for the last 15 years versus the last 10 to 11 years for the clothianid and imidacloprid. Clothianid and imidacloprid are the most detected compounds in the groundwater compared to thiamethoxam, and the ones that also exceed the most the chronic aquatic life benchmark for invertebrates. And as well, we also have that imidacloprid is the only compound that actually has both exceedances of health advisory level and acute aquatic life benchmark for invertebrates. So what factors affect instead neonicotinoids? And things are a little bit different than the nitrate. You see, if you remember when we talk about nitrate, we did see some sort of influence related to the well age, while here we actually saw basically no relationship. It's a flat line. We have that the probability of detecting neonicotinoids in groundwater is not affected by the well age at all. We look again at the well depth, and we saw a similar relationship for the nitrate, not exactly with the same range of probabilities, but we did see that the probability of detecting neonicotinoids in groundwater decreases as the well depth increases. So again, if you have like a more shallow depth, you're going to have a higher chance to have a detection of neonicotinoids. We also look at the soil properties, and this was actually probably one of the most striking relationships that we found. There's definitely a higher kind of like relationship between the neonics and the soil property versus what was found for nitrate. We saw that the probability of detecting neonicotinoids in groundwater increases as the weighted hydraulic conductivity of the soil increases. So if you have like a low permeable soil, you have pretty much a 0.2 of 1 minus 6 centimeter per second, 10 minus 6, and it's going to be like about 0% if you have basically a low permeable soil. If you have a high permeable soil, it's going to almost guarantee that you're going to find like imidacloprid. I mean, the probability is really, really high, almost up to like 90% when your hydraulic conductivity is really high. We also look at the clay content, and we found that the probability of detecting neonicotinoids in groundwater decreases as the weighted soil clay content increases. So, for example, if you have a section that has a 5% content of clay, then you're going to have about a 50% of probability of detecting clothianidin. While if your basically percentage of weighted average clay content per section is above 15%, you probably have almost a 0 chance to find neonics in groundwater. We did the same exercise again for organic matter, and similar relationship to clay. We found that the probability of detecting neonicotinoids in groundwater decreases as the weighted soil organic matter content increases. We look also again at the agricultural land use. Of course, we did not consider septic system just because they're not a source for neonics. And so we jumped directly to the agricultural land use, and we found that the probability of detecting neonicotinoids in groundwater increases as the percentage of agricultural land use per section increases. So again, if you have a 20% agricultural land use per section, then you're going to have about a 20% probability of finding imidacloprid in groundwater. If you jump to like 80% of agricultural land use per section, then you're going to have a 60% chance of having detection of imidacloprid in groundwater. So some takeaways about neonics. We compiled over 2,000 neonicotinoids data collected from non-public water systems. So again, private and monitoring wells in the CSGCC area in the last 15 years. Imidacloprid and clothianidin are the most detected compounds in groundwater, and imidacloprid is the only compound that has exceedances of both the acute aquatic life benchmark for invertebrates and the health advisory level issued by the DHS. and increasing hydraulic conductivity, percentage of egg land use per section, increase the probability of detecting neonicotinoids in groundwater, and increasing well depth, soil clay content, soil organic matter content instead decreases the probability of having of detecting neonicotinoids in groundwater. So some final remarks of kind of like, you know, lessons that we learn off of this study is that definitely a better plan should be put in place when we decide to preserve data, and ideally some data validation should be performed. And let me tell you that the compilation of the data should not be an effort that is done every 70 years. It takes a lot of effort when you deal with so much data, and so much more error is guaranteed to happen the more you collect and you never check on the data. So hopefully, you know, this is gonna, it's kind of like a message that I care a lot about, and hopefully, you know, you're gonna move forward to having better collaboration and better like data sharing kind of processes that and data compilation that will happen regularly, hopefully annually. We do have a lot of data, at least for nitrate, and definitely a more strategic sampling effort can help answer more questions. And I also wanted to like make you aware that the database that was out of this project did not only focus on neonics in groundwater or the nitrate in non-public water systems. So we also collected data of nitrate in public water system, neonicotinoids in surface water. The database also includes addresses, points, biosolid spreading, manure storage locations, spills, septic system, agricultural land use, past and future. So there's a lot out there, and please check the database out because there's so much potential. There's so much more things that can be done, and we could have done literally just from a time, you know, perspective, because we only had basically 11 months to do all we did. And, you know, agencies, counties, institutions will continue to collect nitrate and neonics data. And I really am a strong believer that collaborations between stakeholders or even individual, you know, members of the public or different, like in general, stakeholders or policymakers that are invested in this process, there should be some more collaboration for better understand what all this data means, how do we better understand this process in terms of like contamination, and also for, you know, having a common goal that is in general protect the health of the human health and the environment. So where can you find me now? Just talking about a little bit of, you know, potential collaboration in the future that might be beneficial for you know, both ways. I'm currently a hydrogeologist at the Wisconsin Department of Agriculture, Trade and Consumer Protection. And so I'm continue working especially on problems related to pesticides, including neonicotinoids. I manage primarily the pesticide monitoring program from private potable wells in Wisconsin, and as well the monitoring program for pesticides in surface water. And I also manage the DACAP funded groundwater research through the Joint Solicitation of Wisconsin. And if you want to know more about what we do at the DACAP Environmental Quality Unit, please just scan this code, and it's gonna direct you to the reports that we issue annually, and also all the multi-year reports whenever we do a big kind of like data analysis of the data that we collected. I also wanted to point it out that starting from March 27, we started our 2023 statewide survey for agricultural chemical. So our goal is to sample about 400 wells, private potable wells across Wisconsin. We are collaborating with the USDA National Agriculture Statistics Service that is actively collecting the data. And we do analyze every sample for nitrate and over 100 pesticide compounds. And that's completely free of charge for well owners. So please, if you are invited, if somebody's knocking at your door, is from USDA, the NAS. So again, the National Agriculture Statistics Service is from us, and please participate to this effort because it's highly informative for the well owner, but also for us. And I'm just gonna hand it over to Mike that is gonna talk about the final deliverables of the project.
Thank you, Carla. So this is the easy part. That was the heavy lifting that Carla shared. And I'm just here to kind of round out, to provide an overview of some of the deliverables prepared as part of this project and to walk you through those just so folks know what's available with the study. So these are the pieces of information we really wanted to make sure folks know about. Again, we've added QR codes for folks who can screenshot those now or also later online. We'll make those available. But we have a final report, which you see here on the left, which is what Carla kind of walked us through the highlights of. One of the key things we'd also like to point folks out to is Appendix D of that report. This is a 433-page PDF, I remind you, for the final report. And on page 166, if you fast forward to that, you'll see this resource that we prepared. I have a couple of slides coming up that provide some more insight into that. But this was part of the deliverables that we wanted to be able to emphasize, which was to package up existing resources, point people, interested stakeholders, the public, other agencies towards some of these materials. And then lastly, a publication which just came out yesterday. There's nothing like a public event to get publications out. But this is now, I'm pleased to report, available. Like Carla said, we encourage folks who are interested to track that down. This is the publicly available version. We've also been working to get a county version available for the county land conservation departments and GIS staff. And then at the Wisconsin Geological Natural History Survey, we're maintaining sort of the master database, which could be used for future research projects. So as promised, this is a little bit of a detail. I know this is small to see maybe from the room, but this is the table of contents in the Groundwater Quality Resource Guide. Again, the focus of this was on nitrates and neonicotinoids, but we're really giving folks an overview. And the thing I'm particularly proud about is we're trying to link people towards animations, towards videos, towards interviews. You'll recognize, I'm sure, some familiar faces of people active in the Central Sands from the UW Stevens Point team and other researchers. We're trying to provide sort of a historical framework, links to information about the regulatory history, current situation, and also look into other states across the United States. You know, how are folks dealing with nitrate in groundwater in neighboring states or even places as far away as California? I know we don't like to compare ourselves to California for different reasons, but one thing to think about, knowing that Wisconsin is one of the top vegetable producing states in the country, so is California. So they, believe it or not, have similar regions with high elevations of nitrate in groundwater, and they've been trying to come up with some novel approaches of how to deal with that. So there's some different materials there, as well as the appendix. There's a number of nice resources we've packaged up from counties and different places who've been working on these issues. What did I have in more detail here? So this is, I think I kind of explained this, but the WGNHS data series, this is a new publication series that we've been releasing, and it's really trying to package up databases and make those available for GIS savvy people. And like I said before, there's a county-only version that we, I think, just distributed in the past week. So some of you in the room may have received that information or be aware of that. That's in the hands of the county conservationist teams and their GIS staff. And like I said, we maintain the master database, which we hope can be applied for future research. And we actually have some projects in the works to do exactly that. I also want to point people to this webpage. This was developed, intended to serve as a dashboard for finding resources connected to this project. I've sent out emails in the past couple of weeks pointing people to this as well. But this will live on. Video recordings from tonight's presentation will be captioned and edited and added to here as well. So feel free to tune back in to that. I will say, sort of on a personal note to folks, I'm actually going to be wrapping up my tenure at the state survey in about a month. Our family is moving to Switzerland. My wife is Swiss, and this is a big move for us, but we have a number of other capable hydrogeologists in our office who would be more than willing to work with folks on projects going forward. So just to let folks know about that on my end. So for the what's next section, I think we're going to kind of tag team this collectively and then move into the Q&A session. Yeah, I'll just lead off with this. So like I alluded to, the database that we've been compiling, part of the effort that Carla worked on at the survey before joining DATCAP was to develop a new proposal, which was funded by the U.S. Geological Survey. And this was, I believe, a 2-year study. And I'll just read the title of this. It's PI'd or led by Professor David Hart in her office with another postdoc, Emily Baker, who's at the Wisconsin Geological Survey. The two of them are spearheading this effort. And it's basically, using the nitrate data for this forecasting model, looking at climate and nitrate loading within the Central Sands region. And the idea is to use the nitrate data essentially as a calibration set to understand how nitrate is moving sort of from a transport modeling perspective. So it should be a pretty powerful way to get at some of those things. And maybe for the CSGCC, I'll pass that back to Jen.
Absolutely. So, there's always a question about what do we do with this data afterwards now that we've kind of taken a look at it and assessed and analyzed it. And admittedly, that's something that we're still talking about and trying to chew over and formulate a plan for. But there's definitely been a couple of things that have come to mind that have become very apparent through this study. So one is that the counties and the CSGCC have really been taking a look at how we monitor and the strategies that we implement in sampling for these entities over how we are informing our monitoring strategies. You heard Carla say, some of us have taken the scatter shotgun approach at sampling or filling in gaps, and perhaps that isn't the best method to answer the questions that we really truly want answered, such as that, what is the trend over time? And so we're really assessing that. And then we're also looking at creating strategies across the 6 counties where we can compare apples to apples amongst all of those counties and kind of look at uniform data sets across them in a similar way in similar time periods for assessing what that data has to tell us about where things are at. A big part of this project too that was kind of in the background behind the scenes was there was a big communication and outreach component of this, of not only reaching out to communities and stakeholders, but really assessing and looking at what populations are within these counties, who do we need to be talking to, the underserved populations and where those are located, challenges associated with communicating those. And that wasn't specifically tied to this project, but is a really valuable data set for us who work in these counties and who work in local government and have some of these challenges communicating with these types of populations. And so that's been a big part of kind of further communicating those efforts out into those, and something that we'll continue to use along the way.
Yeah, I just want to there's an extensive list of people. I think people can miss my face, but so yeah, just thank you. I don't want to go through all, but there have been conversation, there has been an advisory group for this project that involved, people from UW Extension, USGS, DACAP, DNR, UW Stevens Point. We had conversations with the Wisconsin Potato and Vegetable Growers Association. So we try to kind of involve, as many people as possible, for inform them, but also for us to understand what were the questions that they want us to answer. So, hopefully we answer some of the questions. There are definitely a lot of open questions that remains, but again, if you want, you can definitely now you can have a tool now with the database to answer the majority of the question that you might have. And I think
with that, we'll open it up for questions and discussion. And this is really intended to be, I know some folks joining us remotely via chat. And this will be a thing too that we hope to be able to package up and provide online as well. So raise a hand, or I don't know if we have any questions on chat to lead it off. Okay. Yes, sir.
During your study, especially for homeowners along lakes or fertilizing and that, does that impact? Was there any recommendations for that? Individual homeowner, if they want to fertilize their lawns or they're trying pest control on their own, which could leach into our water systems?
Yeah, this is like kind of like a county area like study. We did not look at specific like kind of regions to kind of answer those questions. We just kind of, because we had to deal with like 70,000 data points, for the nitrate, we couldn't just look at like individual homeowners. And there's a lot, there's a lot of land use, there was a lot of use of fertilizer and pesticide that happens across the 6 counties. So we did not look specifically at those, at individual and making those recommendations. There's definitely, if you want to look at more in depth at this kind of questions, you can definitely use the database to answer those and look at the sections perhaps that have, more, urban use. We did not we did try the urban use kind of statistical analysis. It didn't make it into report because it wasn't like a straightforward kind of a connection between the nitrate use in urban area just to fertilize your lawn. The use of nitrate is definitely less, there's less amount of nitrate used in your fertilizing your backyard compared to what is used by the agricultural, processes, or in general that might perhaps leach by a septic system. So we had to make some sort of like decision in terms of like what, there are millions of variables that could be taken into account, but we had to make some decisions on like what are the most potentially influencing controlling factor here. So again, we did not look at specifics kind of like in regions, around the lake or use of fertilizer or pesticide that might be a little bit less in terms of amount compared to other, sources.
Question from the chat. Is there any way to look at or account for legacy nitrates? Nitrates that have been there a long time.
Yeah, so the database has a time component, so you can definitely look at least at the nitrate concentration. There's nothing about the use in the database and nothing about the use that we could really found, because apart from like just statistics that my kind of estimate a use or a leaching of nitrate, we couldn't have something to refer to. But, as kind of Mike pointed out, the idea of the project that is going to be done, and it's currently done by the Wisconsin Geological and Natural History Survey, is actually trying to estimate a use, trying to estimate a leaching, compare that to what actually the real data is, and through the models kind of figured it out if, there is a legacy of nitrate, how old is the nitrate basically, and kind of answered those questions. So it's definitely a future effort. It's not, it did not happen through this study, but, the future effort could make this, potentially answer just through this database. So it's one of the example of what is going to happen next.
Next steps. Yeah. Sure.
Adams County Supervisor Josh Pozdolski here, Newchester. And I noticed there's been a lot more use of salt or brine on our roads, county roads, highways. Has there been any testing done to see how this might be affecting our water supplies? Being that, even not only the groundwater, but our lakes, our rivers and streams.
Sure, absolutely. Yeah, so chloride is one of the parameters that is often commonly measured, especially if you go to like the University of Wisconsin Stevens Point Laboratory. Chloride is one of the common constituents in what's called their homeowners package, which is the basic water sample package. So this study did not look at it specifically, but where I would direct you is the Wisconsin Well Water Viewer is a great repository of information. It is focused specifically on private well samples, but chloride is a constituent in there, and you can look at and you can zoom in by section and see what the chloride concentrations are in the section. And you will certainly see areas where those light up and are much more significant. And a lot of the times those are associated with like either an urban land use, so pavement, impervious surfaces where we see a lot of road salt spreading. You would have to go more to sometimes individual counties to see the surface water component of those if they're sampling there. But in order to get at that data, the best way to do it is through the DNR's surface water viewer. So when they have citizen monitoring that takes place on the lakes, those people will sometimes be sampling for chloride. It's not quite as common, but that data is stored through that DNR surface water viewer. Or there's also a great new program through the Isaac Walton League called Salt Watch that's available. And if you Google that in, it will bring that up and you can see where the people are voluntarily sampling for chlorides along there. So there's multiple sources of information. I believe the DNR database, I know the surface water viewer are links in that groundwater resource guide that we posted up there. So it tells you how to access that information. They're absolutely fantastic resources that are publicly available to anyone who wants to use them.
Thank you.
All right, I think we'll just go back and forth, chat.
Sure.
Person, chat in person. So you put together a best practice or schema for future well data collection and data storage. Say that a county or municipality wants to start collecting data that will be most compatible with these existing data sets. You have a protocol, something for people to follow.
So within that groundwater resource guide, there is actually a piece on how to establish kind of a drinking water program or a well testing program that kind of talks about the basics of going through that. When us as the 6 counties have gotten together and talked about our own efforts on sampling, that's a hard question to answer between counties because so much of it varies on the specific questions that the county wants answered or that they feel are most important. And then also availability of finances really is a big thing that will influence how and when sampling occurs. And that can really vary from county to county. So there are some basic things that can be kind of standardized between that. I think those are touched in on those resources as like basic parameters that we should be looking for sampling for. But beyond that, it gets tough to do that unless you're really kind of coordinating those efforts. I don't know if.
And just to know, as much as I love you speaking to me in the camera for the line is over there.
Sure.
So.
Yeah, I can just add that like some effort was done along the way with some of the counties, you know, like I believe it was like Wood County that we work with to kind of identify wells that had concentration between a 5 and a 10 that had at least 2, you know, sample and data points to kind of look at more of a strategy of looking at trends over time. So more kind of like a targeted, let's say, sampling strategy. So we did some work with the county along the way. You know, it's kind of like between us and the county. Didn't make it again into the report, but it's one again of the example of how this database could be used.
And I'll just add there again too, I think part of the hope with the database and making that available to the counties is that their counties would be able to, you know, essentially start programs and to engage folks and start to, you know, adapt some of the findings to targeted areas or get additional information that might be specific to their county to kind of guide that. So it's the tough thing with this is that it's difficult to provide like a flow path that is going to satisfy everyone. And it really needs to be developed at the county scale with involvement from the towns and including other agencies and folks who can help support that. So that was part of the goal for this study was to kind of kickstart and help support that process. Do I see a hand up front?
With
Oh.
the lady, sorry.
Start with you. We'll come back.
So neonics are not naturally occurring, are they?
No.
Okay. So they accumulate over time. Is that what happens? Is that what you found in your studies?
Well, the per se, it's not that we can say they accumulate over time because we don't know specifically what is the use. We don't know if people are stopped using it to say, it's like, okay, I've used it 10 years ago and now it's accumulating. There's definitely it's not a natural, occurring, they're pesticides and, there's definitely a transfer. It looks at least from the stats and in general, it's well known that there is some sort of absorption behavior. So these compounds stick to like clay. And so that might help with the degradation process of these compounds. And so that's why you might find or not find, but they definitely, the more you use a compound, the more it's gonna accumulate in the environment. And there's definitely sometimes a lag time between when you apply and when it actually is gonna show up in the groundwater. We, in other studies and other research, it's in the central sand app and with the surface water data that we had, and we actually from DACA, now speaking as a DACA employee, we found that even though neonics potentially were registered in 2003, we actually found in surface water, and some of the surface water just since 2019. So there is a little bit of a lag time that makes the question of the legacy a little bit hard to answer.
I've got I guess I know my question. I want to answer it anyway. The survey showed us a lot of data. How do we as homeowners get the data back into the system?
You mean?
So when you get your well
Okay,
tested.
I drill a well, I get it tested. How
Okay.
does that get back into
So
your data?
I mean, that depends, how you test your water through what entity. UW Stevens Point, even though it's not sharing all the details about the well owners just because it's a privacy matter, it still stores the data and makes up to the Well Wisconsin Quality Viewer. There are other tools, I don't know if the counties are thinking to a strategy to have kind of like a representative that will collect the data. There are other tools online, like the EPA, National Water Quality Database, where everybody can register an organization, and that could be just an organization of volunteers that go out and sample and upload the data nationally. There is a lot of places where you can actually go and share the data, and I'm pretty sure that if you contact somebody I don't know, UW Stevens Point, and say, hey, I got this data point, it's not that they're going to discard your data, right?
Is this data kept in at UW Stevens?
It depends on where you if you sample through so if I get your question correct, you're asking, so if I sample where my data is going to go, it depends on where you sample. If you sample through the UW Stevens Point, that data is going to go through the Well Wisconsin Quality Viewer. And there's a lot of still already of collaboration that is happening. The UW Stevens Point database also includes partially the data of the DNR. So there's definitely a conversation that happened, in terms of collaboration and putting together all this data.
So your database will be added to?
No, the database that we have, basically built half of this effort. It's gonna live there, and I don't know if there's gonna be an effort of updating once in a while. But I think it might be just one-time effort, and then or maybe it can be used as an exercise to continue building up that data.
So I'll jump in here too. So one of the things I would say as a homeowner, if you really would like to see your data kind of shared or put out into that public space, I would encourage you to utilize a state certified laboratory that is public. So something like the State Lab of Hygiene, the county laboratories that individual counties have, the water lab at UW Stevens Point, they are able to more easily share their data in those public entities or in those public databases versus someplace like a private laboratory. And it's not that they aren't great, but if you want your data out into that public realm, that's a great first step to take as a public or as a homeowner. As far as creating this database goes, I think there will be an effort to keep this database at least up and running to some degree. All of the counties have plans to continue to collect data, and we would like to see that fed into this database so that at least our county level data that we take and that we sample is all going to go back into that. The other thing that I have found really interesting in this project is the state is starting to have this exact conversation at a much larger level about creating and sharing these types of data. So the DNR right now is working on a much larger project than this that is kind of trying to replicate this, but on the state level, because there is a recognized need for local level information, for local decision makers to have much easier access to this, for homeowners or people who want to be informed. So I think over the next years, because this is a really labor intensive process, you will start to see that come out in that public space too.
How secure is your funding to achieve ongoing monitoring and to improve the quality of the data collected?
Ooh.
Get on, Jim.
That is a county by county question. So it depends on how each county has kind of set up its funding. So right now we see a lot of counties, and not just in the Central Sands region, but across Wisconsin, a lot of counties are utilizing ARPA or federal funding from COVID relief to accomplish sampling. It's because in that COVID relief funds, there is a specific line item that says water quality testing is allowed to be used for these ARPA funds, which make it a pretty easy sell. So we're seeing a lot of counties utilize their ARPA funding. That funding is going to only stick around through 2026 at the absolute longest. So I think we're going to see this major push of testing over the next few years. And then it's going to be up to each individual county, you know, the importance that's placed on that for continued funding after that. That's probably about the best answer I can give you guys.
Another in-person question, otherwise there isn't one yet. Go ahead. All right. This is for Carla. Did you break out different types of agriculture, for instance, row crops versus perennial crops versus grass-based agriculture?
No, we did not, but that's something that I believe it should be done. There's going to be some differences if you see, you know, sections that have perhaps like different cover crops that might have an impact, especially on compounds like neonics. So yeah, no, we did not do it, but hopefully somebody will in the future with this data.
In your early slides, where you were doing your testing and you had a concentration, there was like a definite line through the counties with those higher testing things. Was it agricultural? Was it population of people? Could you put your finger on it? What that?
Yeah, I can go into the slide, but I know what you mean. It was like that north-south trend that was going through.
It follows the terminal moraine.
Yeah.
The terminal glacial moraine. So at least for us, it's a combination of different
Yes,
things.
correct.
A combination of land use, the predominant land use type, a combination of the soil type. Those are the two biggies for us. So really high intensive ag use in those areas. It's prime farmland, very sandy soils that allow for very rapid infiltration of both water and then anything else that's applied with it. It's kind of like a perfect storm. And that's why you really see that area light up.
Yeah, there are maps, like even just not considering the land use, like that show the kind of like groundwater susceptibility. There is, again, a combination of soil type, water depth, you know, water table is pretty shallow. And so the aquifer, the sand and gravel aquifer, it's very vulnerable. There's nothing as a confining unit that kind of prevents. And in general, the soil, you know, as much as there is some clay, but there are areas where there's basically pretty much no clay. So all you have is just sand, and nothing sticks through sand, really.
Let me continue my question. So let's expand that further north in the state and further south. Would that
It's all the same concept. It's kind of like a combination of always like a land use, but also to a natural vulnerability of your system. It's kind of like, you know, if you had COVID, right? Everybody reacted in a different way because their system had like is different. And it's kind of like the same as for groundwater and for like aquifers. Every aquifer and every portion of the state, because of a combination of soil, water table, and it has some more vulnerability to be contaminated. And then if you combine that to more ag intense or a general specific like land use that it's more like prone to have, you know, a high use of nitrate or pesticides, then you're gonna have the kind of hot spot.
You kind of see this taper off though. It doesn't really extend much farther to the north. It goes a little bit farther to the east over into Waupaca County. And then you'll kind of see it taper off down to the south. And that is because it follows that glacial, the end moraine of the glacial area, which really influenced that geology. So a lot of this is influenced by that leftover glacial geology that we're dealing with under this area. So that's why it perfectly follows that terminal moraine there, that hotbed.
To relate to that with the 74,000, is that including the data that you had to throw over this 51%?
Yes, that does include the data that might not have a good, you know, estimate on the well depth. We decided to keep it just because the purpose of, you know, the questions that you can answer with this database might be different. You might just not be interested in the well characteristics, but you're still interested in the concentration. So we decided to keep that, but just to have a trace of like what you're looking at in terms of resolution. We did discard the data that had a well location that had a resolution that was worse than a section. We had some wells that were like county centroid or state centroid, which to be honest, they don't really mean a lot because it means that, you know, well, it could be anywhere in the state. We're not even sure that's in the 6 counties. And so we kind of discarded that data. So we decided to only keep the wells that had a location resolution of at least a section. And then yeah, also the bed kind of data in terms of well characteristics, just because again, some people might just be interested to the concentration and not wanting to look at that type of data.
And that isn't necessarily saying that it was always bad data. We didn't start really record keeping on well characteristics until 1988. So in terms of that data, that's relatively new when we're talking about this. I mean, there's 30 some years of data if we're going back to 1953 that we didn't even necessarily keep track of well characteristics. So that's been a challenge for us too. And especially when we want to look at, you know, well casing depth below the water table, is that a lot of those cases we're looking at it limits the amount of data that we're able to do that a type of analysis on simply by the record keeping time period that we have available to us.
Another comment from the chat is fantastic presentation, got lots of kudos. After completing this study, would you have included any other potential factors that would impact nitrate concentrations?
I mean, diving into a little bit the specific of the land use probably would have shown some other insight. Yeah, and just looking perhaps in more detailed areas, but I think that overall we captured like the main factors. It wasn't easy, to be honest, because even just like behind the idea of the soil properties, it took us some time to come up with that. And so it's, you know, I would say that every time I see a contamination, I always think about general land use, soil type, and maybe we could have looked a little bit more at the water table, but again, those were actually not great of a record. And the water table that also is recorded on well construction report is the water that, you know, it's at that time of construction, and there's a lot of variability based on that. And so we also at certain point, we kind of look at the bedrock, but honestly, we do not have a great information on bedrock depth. There is a map of the 80s, no, maybe before then. But, you know, when we compare to some of the well construction report, they were not really speaking the same language. and we did not have a lot of data to actually pull out the bedrock depth as a controlling factor. So there's definitely a lot of more variables, but that's all we could do basically with the amount of time we had and with the quality of the data that we gathered.
Was there any distinction between irrigated and non-irrigated?
No, we did not make that distinction. We did, one of the parameters in the database that it's kept as however the well use. So there are some wells that have a specific in terms of like irrigation well. We try to also keep track if that well was a high cap well, which most of the time means it's irrigated. So we did not make that distinction, but it's definitely something that you can track back by just looking at private non-potable wells and if they have like a high cap well or not. And you can look at that.
That'll be one of the beauties about this database too, is since it is publicly available to the public and also to the counties. If counties have those specific questions, they can go back into the database and pretty easily overlay those layers from the data within this database to really tailor it to the specific needs of the counties to answer those questions.
Just, so on the neonics, you had mentioned that there was a human
Health advisory level issued by the Department of Health Services of Wisconsin. So, no, you just go ahead.
I was gonna say, was there a human health component where what you said one of them didn't they affect the amount that was in there affected human health?
Yes, so basically only imidacloprid exceeded so you see here that the health advisory level, so how it works that DHS just conducts some like toxicology study to come up with like some advisory levels. And these might or might not become standards in the future. It's not up to us. It's a DNR managed process. But you can see here that clothianidin had like a health advisory level of like 1,000 micrograms per liter, so it's really high. And here the imidacloprid is definitely lower. So of course the chances of basically having exceedances are going to be higher. And yes, imidacloprid is the only compound that we found being exceeding the health advisory level of 0.2 micrograms per liter. Yeah.
Oh, sorry. All right, another question from online. Will the new Inflation Reduction Act and bipartisan infrastructure law help people to improve their private well water and/or assist counties and private parties with monitoring and database management costs? Basically, do we have money in those bills?
That is the hope, yes. So it is my understanding that they are working as that money trickles down, because those are federal bills. As those federal funds trickle down to the state, it is the hope to make those available through communities and increase funding for community testing programs throughout the state. So hopeful that that will happen.
So there is money earmarked in those for water quality?
Potentially, yeah. It is my understanding that the state is working on that.
Because this data will be publicly available, can you define what level the data will be available at?
Sure.
So the majority of the data, I believe, except for the spills, is at the section level. So you're gonna have like nitrate you're gonna have individual measurements of concentration, but the location is gonna be at the section level. Hello. Okay. And that is because some of the data had that kind of resolution. Some of the data, even though they give you like a lot long, then the accuracy, it was only down to like a section. Oh, what's going on? Okay. And so in general, just to kind of, especially for public water system, we just wanted to make sure that the privacy was kind of kept on that, even though, some of them are publicly, available. So yeah, we just decided to go down that route just to have it a little bit easier, because it would have been a little bit of a problem to plot data of like this is a point, but it's not really a point. And so that's why we decided to just go for the section. Yeah, and the county only will have instead more in-depth data with Wisconsin unique well number, just because now it's going to help more in, a targeted kind of a sampling approach, to kind of like go back to some wells where like understand what wells were sampled or not sampled. So that's going to be a more kind of a only county kind of database that there is going to be a little bit more in depth, but even in the public data, again, you're going to have all the information about the wells and the concentration. The only thing is that we kind of masked we never really recorded at all the owner of the well. It's not really an information that in general is shared by any party. But we also masked the Wisconsin unique well number and again, the lat long, so we only kept the location, but you have time and all the well characteristics as well.
Is there an effort to monitor ongoing presence of nitrates and neonics in surface water, as well as proximity of wells and surface water to point contamination by cables?
So I can speak at least from a neonics perspective. We do have a surface water program that I manage that is looking at pesticides in surface water. Our resources are unfortunately limited, so we have to always make decision in terms of where to go. We usually sample about 10 to 15 locations per year, and we have been doing this for 15 years now. So I'm working on kind of a release of a 15 years report on pesticides that will also include data on neonics for surface water. And there is a lot of effort for nitrogen in surface water. And again, if you just look at the DNR SWIMS database, you're going to find a lot of data for surface water. And the purpose, I don't know if there are projects that are specifically related to CAFOs. I'm sure there are, but again, you can go and double check that data on the SWIMS. We did not include nitrate in surface water because that would have been, again, an absurd amount of effort to do that, because we're not just talking about few thousands, we're talking about hundred thousands of data points, and so it will take basically another 6 months at least to do that. So we didn't have time.
One more. Yes. Okay. Will PFAS monitoring be part of any future study?
Not from DACAP.
That's an easy answer. I think we will probably start to see that. So DNR had a concerted effort over the last year to sample wells across the entire state. It was the first attempt to sample private residential wells for PFAS. So I don't remember the exact number that they did. There were wells, so they overlaid a grid over the entire state and chose wells from each grid space to sample for PFAS. So that's the first time private residential wells have really been sampled. Many of the municipalities, of course, those public drinking water supplies have voluntarily submitted to PFAS. If we see a formalized PFAS standard, I think that sampling established within the state, I think we'll start to see that sampling increase because we'll have a standard that we can compare that to. Up until now, without a standard, that's been a little wishy-washy as far as PFAS goes. I also think that one of the big barriers to PFAS sampling is the cost and the lab availability. It is not an easy thing to sample for. It's my understanding that cross-contamination can happen pretty easily in those samples, so they have a pretty strict sampling procedure. There's only a few labs in the state of Wisconsin that are currently certified for PFAS, and those samples run in excess of $300 per sample. So right now it's pretty cost prohibitive to do that. But as it becomes a more common thing that we're talking about and starting to see, I think we may see a switch in that. So
I just want to add on that, because PFAS or even neonics are really they're really expensive to do by your own. again, whenever invited, participate to these efforts from the state, either if it's from DACAP or DNR, because it's a unique opportunity and it's gonna save you a lot of money.
Jen, this is kind of a question maybe for you, but if there were folks in the room who wanted to learn more about the next steps, especially if CSGCC, if, you know, the county members, their next steps and how they're going to use this data, is there somewhere that they can go, or how can they get involved?
Sure, absolutely. That is a great question. So my first suggestion would be to go visit your local land conservation office at your county. So those are folks that have really been tuned into this study, that are often involved in the collection of water quality data. They're a great resource. So all of them have a representative that sits on the CSGCC as well. And then also your local county health department is also a great resource for information. So those would be two great places. Otherwise, talk to them, find out when the next CSGCC meeting is. We've been meeting monthly. Those are open public meetings for anybody who is interested, and they are welcome to attend and to learn more about the group and what's happening through that as well. So that's a good question. When is it, May? Bill?
Yeah.
May.
Fourth Mondays, will probably be at the Hancock Agricultural
Research Station. Yep, that's usually where we meet, 10 a.m., fourth Monday of the month.
Is there a website that posts any of that?
We do have a website. If you Google Central Sands Groundwater County Collaborative, I don't know that the monthly meetings, meeting dates are routinely posted. So that's the challenge there. It's just a challenge to kind of keep that updated on the website, but they do have a website.
We've had a very intrepid group online. We've had over 30 people that have stayed online the entire time.
Thank you.
Great.
Thank you to them.
Well, thank you all. We'll stick around. We got to work our way through some of these snacks before we.
Help yourself as you leave.
Yeah, we'll be here to continue discussion as needed. But again, thanks everyone for their time and joining us online as well. So thank you.